Hi there, it's Dr. Embody to talk to you about Project 10. This is a project that uses classes. The final project will be one where we design classes. And this one is somewhat like the lab that we had where we used playing cards at a deck. So we had a cards class and we had a deck class. And in this game, because it's played on a board with pieces, we're going to have a pieces class and a board class. And the idea is to, just like we were playing a game of cards, you may want to go back and look at that lab to see how it worked. That relates directly to what we're doing here. We've designed a class, and you have to build a game that uses that class. The game that we have here is called Reversi. And some Americans may have seen it under the brand name of Othello. We give you a link to a place to play it. You gotta play it, and if you haven't played it yet, go follow that link. Shut this thing off. Go follow that link. Play the game. Get a sense of it. It's played with black and white pieces. And the whole point is to capture your opponent's pieces by replacing, say, if you're the black one, you try to get as many white ones and convert them to blacks. And at the end of the game, the one with the most pieces wins. So with that, go look at the game, see how it's played. And then we can take a look at how it is done. What we're asking you to do as a project. We give you two files. One is the Reversi file, which has the two classes in it. It's got the pieces class and it's got the board class. And then we give you an outline of the proj10.py. It has some of the functions completed, including the main, and you have to complete the rest of them. Got to get a sense of it before you're going to be able to complete those. So let's take a look. The board that we have ends up looking like this. It's a bunch of lines and numbers and so on. And the game starts with two white pieces and two black pieces in the middle. And that's, in fact, one of the first functions you'll write is how to do that. But so we have a board and we have some pieces on it. The board has numbers along one axis, letters along the other. We in fact limit it to A to Z, so you can have 26 of them each way. This particular game is an 8x8. It will always be square. Might have an even number of sides or an odd number of sides. The Reversi.py has two classes in it. It has the board class, and then it has a piece class. Again, like what we had with when we had the card games, where we had a deck and the playing cards. Each piece has two colors. It could be black or white. We give you the code for those, or in fact, the one that gets run on Mimir uses B and W. You need to take the time to figure out how these classes work. Like any class that has an init, what are the attributes of the state of this, and it has a color, and it will either be black or white. And then there's a bunch of methods. Color tells you what color it is. So you need to use these methods to access the attributes, because the attributes will actually be different on Mimir than when you're running it on Spider. You have the ability to flip a color from one to the other. There's Booleans. Is black, is white. Flip a bit, and then of course you have to display it with whatever the symbols are. And at the very end is a little test piece that shows you how to use some of these. So that was the piece. There is also a board, okay. And the board is logically in that arrangement. So there is a length, that's how many there are on each side, and then there are cells, which turns out are is a list of lists of rows of the that represents the board, and then these are described, each method. Is it free? How do you place a piece on the board? How do you get the values that are on the board? How do you remove something from the board? Is empty tells you whether the whole board is empty. Is full is the opposite, that's all filled up. And then there is display, which goes and will show you all the pieces on the this will display the board and then put all the pieces out there. And there, the SDR here is rather messy, but you don't have to worry too much about it because we gave it to you. Then the proj10.py has a bunch of functions that you have to do. We gave you this one as the most complex one. Encourage you to take a look to understand what it in fact does. And then there's all the other ones that have to be filled in. But we gave you the main one. We also gave you this other one that does one of the figures, so you can use that for testing. So in the document there's a board configuration called figure 1. It's pretty complex. It gives you something to test against while you're developing, and we gave that to you. In fact, it is, there it is, figure 1. So when you execute that particular figure 1 function, it creates a board in this configuration, and now you can use that for testing. One of the things you notice on here is that we have letters down the left side and we have numbers across the top. So this first position is represented by a 1. This next position is by a 2, and so on. And let me get that out of here. And then, so like this position here. Actually, let me start drawing. If I want to look at that position, it's represented by the letter B and a 3, so we say that's position B3, but internally that is a list of lists, and the index of this, of course, indexing of lists 0, 1, 2, and 0, 1, so this cell here will be represented by row 1 and column 2. So one of the first things that you have to do is write a function that takes a pair of letters and converts it into the index. So when you play the game, you use the letters. Internally, that list of lists is indexed by that particular value, and the function is called indexify. And then, not surprisingly, we have another function that does the reverse of that. If you have an index, what are the letters that are associated with that. And so the function that I'm talking about, the pair of functions, there's the indexify, right, where you give it a position in letters and it will return a pair in numbers, and then the de-indexify does just the opposite. There's a function that initializes the board. That's what creates this initial board configuration with 2 whites and 2 blacks in that order. Then there are other ones, count all the pieces on the board. This one where you get all the streaks, and we give you that function. But let me spend a little bit of time on it. All right. Imagine that we start at location 3,3. And what that means is that we go over 0, 1, 2, 3, and we go 0, 1, 2, 3. So we're looking at starting at this position. And what we want to do is we want to find all the ones that I can capture. So we're talking here about, suppose I put a black in here. And the rule is going in the north direction, the east, the south, the west, and then also in the diagonals, northeast, southeast, southwest, northwest. What can I capture? And the ones that you capture are any of the whites that are up to a black. So I can capture this guy, and I can capture that guy. That's heading east. Heading north, there aren't any white ones here, so there's nothing here to capture. If I head south, starts with an empty space, can't capture. Heading west, I could pick up this guy and this guy, again terminated by a black. If I go northeast, white, white, white looks good. No terminating black, can't pick any of those up. If I go southeast, I see that there's a black terminating, so I pick up that guy. Same thing in this direction, this guy, this guy. There's a terminating black one. Whoops, I got to make sure I get these lined up right. This goes into this one, so that's terminated by its space, so that's no good. And then in this direction, there's a black one, so we pick up this guy, this guy. And so what this function returns is all of the pieces that that I just marked. And if you look down below at what's returned by the streak, then you will see in the east there's a 3, 4 and a 3, 5. So that is row 3, item, columns 4 and 5. And that's these two. And to the west, 3, 1 and 3, 2, that's these two, and so on. And so we return a dictionary by direction, northeast, southwest, and so on, starting in this place with this particular color. So we give you that function, but it's important to understand what got returned by it. And so here they are, from the east, we had those two. From the west, we had those two. The north, it's empty. The south, it's empty. And you want to figure out why that's the case for all those. Northwest picked up 2, and southeast picked up 1. And notice that these started all with values of none. We gave you that. This dictionary gets returned. Got to understand that. The reason that you need to understand that is the next one says I want to get all the capturing cells, not just one. So the one in this case that I just went through was putting a black piece here. What the next function says is go ahead, go look at every single empty spot. So on this spot, then we figure out all the captures from here. And then this, which is an empty spot, we figure out all the captures from there. And we go through every single empty spot and we call the function that I just went over. So we calculate all the possible captures, trying to say, well, imagine that I put my black in every single empty spot. And I collect up all those possible ones because I want to try and figure out which one is going to be the best one. All right, that's what this function does. Get all of them. What does it do? It gets all the streaks. So I just try them all, and then I build up a dictionary. So for example, in the case that I was just working on, it started in location 3.3, so I should be able to find 3.3 in here. Here it is. Okay. So starting in location 3.3, what were all the cells returned? And there they are, all the way up until we get to the bracket there. So we have taken this, and all the cells that are in there appear in this list right there. Okay. So let's take a look. So we see the 1, 1. We see, so that's that guy. We see the 2, 2. We see the 3, 1. There it is. We see a 3, 2. There it is. We see a 3, 4. There's that one. We see a 3, 5. There's that one. And we see a 4, 4. There's that one. So I look at what's returned by this function, and it started here at 3, 3. That's the 3, 3. Each of these guys comes out of reading that dictionary. And then for mirror testing, we sort that particular list. And I do that for every single empty cell in there. And I build up that dictionary, and that's what I return. And then this is a neat one. Get the hint. All right. This now once we have created that function, we use what's returned to now figure out where's the best places to start. So looking at this information, what are the best places to start? And here it is from best to worst. So D4 is the best place to start. And why is it? Because it has the most cells that get captured. So also notice that we will have converted from the indices into the string that represents a spot. And again, these will get ordered from best to worst, most, and then the most cells that you're capturing, because that's what you're trying to do, most to least. And if two have the same, then we do them. We also sort those. Again, that's for testing with mirror. That helps us decide where to place one. Once I decide to place it, then I have to make the flip all the ones. So for example, in this case, suppose I did do, I put a black in this spot. That means that I go and flip these guys, these guys, these guys, these guys, these guys. All right, I flip all of those to being black. They all become blacks. And so that's the notion of we placed our black one and then we flipped all the appropriate ones. Which ones do I flip? Hey, I got a list of those. And I can I can just use the ones because I already know what they are. So that's what that function does, uses the information that we've just done. Then the other ones are you know, quite a bit smaller. How do you determine whether the game is finished? Figuring out who's the winner, that's relatively easy. Who's got the most pieces? At some point inside the loop, we have to choose the color, and then we give you this function. That's it. That's what you got to do. I encourage you to figure the game out first, and then go and start to fill these functions in pretty much in that order that I gave you. All right, hopefully that gives you enough to get started on this. Good luck.